class, we're going to take a look at the relationship between scale factor, the ratio of perimeters, and the ratio of areas within polygons. So we have been talking about similarity for a little bit, talking about ratios and proportions. And what we're going to do is we're going to have this opening activity where we're given 4 dilations of this original rectangle. So we have this original rectangle that's 3 by 2, and all of a sudden we stretch it up here so it's B. So it's now 6 by 4, then we have another one where it's 9 by 6, and 12 by 8, and 15 by 10. And here's what we're going to do. We're just going to take a little while. Why don't you pause this video? Why don't you fill in all these blanks and pay close attention to the units? I'm going to talk about those very quickly. You fill them in, hit pause, and hit play again when you're done. Hopefully you're checking these answers as you're going along. I'm just filling mine in. I've worked these out before. They do have the little formulas above, so you should be good. That's 24, 54, 96, and 150. We all need to agree on these numbers in order for the next part to work out. But the idea is when you find these, in order to find the perimeter, you just say 4 plus 6 plus 4 plus 6. That's going to be 20. Multiply the 4 times the 6. You're going to get 24. These numbers are all very important to us for the next part that we're going to look at, because we're going to start comparing some of these values. To find the scale factor, what we're going to do is we're going to take the widths. That was the first column. We're just going to compare the widths. So the width of the width of rectangle A is 2. The width of rectangle B is 4. Then we'll just simplify that fraction to get 1/2. To get the ratio of corresponding sides, I'm going to compare the lengths of two sides. So we'll take the length of rectangle A, which is 2, and it's not 2, it's 3. I'm going to change some of these numbers. And the length of rectangle B, which is 6, I'm going to simplify that. Oh, I still get 1/2. We'll talk about the ratio of perimeters. That's going to be 10, the perimeter of A, and 20 is the perimeter of B. When I simplify those, I still get 1/2. And the ratios of area, 6 and 24, I get 1/4 when I simplify that fraction. Again, why don't you pause this? Why don't you go through the next 16 boxes, fill these in, then we're going to have a little conversation about the widths, the scale factor, how it relates to each of these other numbers, this scale factor, how it relates to each of these other columns. Pause this, fill them in, and we'll be right back. 2/6, which is 1/3. We have 3/9, which is 1/3. We have 10/30, which is 1/3. And then check this out. We have 6 over 54, which is not 1/3. It's 1/9. So we have 1/9, 1/3, 1/3. How do those numbers relate to the scale factor of 1/3? We'll compare A to D. We'll have 2 over 8. That's 1/4. Over here we'll have 3 over 12, that's 1/4. We have 10 over 40, guess what that is? Nope, it's not 10 over 40, it's 1/4. I circled the wrong stuff. Then I have 6 over 96 is not 1/4, it's 1/16. So how do these three numbers relate to our scale factor of 1/4? Let's try this. We have 2/10, which is 1/5. We have 3/15, which is 1/5. We have 10/50, which is 1/5. And we have 6 over 150. That's not 1/5, but it's 1/25. Lastly, we have 4 over 6, which would give us 2/3. We have 6 over 9, which is, again, 2/3. Can you believe it? We have 20 over 30. These are our perimeters, which gives us 2/3. And then we have 24 over 54. Both of these are divisible by, how about 6? That would give us 4 over 9. Whoa. All right, how are these three columns related to our scale factor? Well, it seems that our scale factor, it's a one-dimensional quantity. We're comparing some widths, so it's okay that these are the same as comparing some lengths. I think those should be the same if they're corresponding polygons. if they're the corresponding sides, and they're similar polygons, those should be the same. Well, isn't perimeter also one-dimensional? You're just adding up all the sides. This is a comparison of, say, like 4 lengths to 4 lengths, which should be the same as this guy here. But this poor area over here, it's 2-dimensional. If we had units here, if we had units here, if we had units here, our units would then be square units, and this is 2-dimensional. So the idea here is that if you were to take this number in this column and you were to square it, well, 1 squared gives us 1, that works out, and 2 squared, oh, that gives us 4. Same thing here, take this number and square it, 1/3 squared should give you, oh, 1/9, 1/4 squared, 1/16, 1/5 squared, 1/25, and check this one out, 2/3 squared, 2 squared is 4, 3 squared is 9, we got it. There's the relationship from the scale factor. The length of the corresponding side lengths, that ratio, is going to be the same. From the scale factor to the ratio of perimeters, they're going to be the same. From the scale factor, you need to square it in order to get the ratio of areas. That's how they all relate. Okay, let's formalize this using some words. What can you conclude about the relationship between the scale factor and the ratios of the perimeter? I think the easiest thing to say is that they're the same. So it says if the scale factor of 2 similar polygons is some idea of A over B, then the ratio of the perimeters, it's still going to be A over B. What can you conclude about the relationship of the scale factor and the ratios of areas? Well, I think the scale factor, if we took it, whatever it is, whatever numbers it is, and we square it, we're going to get the ratios of areas. That's how that's going to work. So the scale factor here is now A over B. The ratio of areas is not going to just be A over B, but we have to square it. And A squared is A squared, and when we square B, we get B squared. That's what we have. We have A squared over B squared. Let's see how this applies to real numbers. Okay, they give us the scale factor of 2 triangles is 3/5. How is scale factor related to the ratio of perimeters? Well, it's the same. It's also going to be 3/5. How's the ratio of areas compared to the scale factor? Well, it's 3/5 squared, so that would give me 9/25. Perfect. Okay, number 6, it says the scale factor is now 2/7. What's the ratio of perimeters? Those again are going to be the same, 2/7. How does that relate to the ratio of areas? Well, we have to take 2/7 and we square it. That would give me 4/49. All right, number 7. It gives me the ratio of areas, 25/16. Notice both of those are perfect square numbers. What's the ratio of sides? Well, I basically have to square root 25 and square root 16. That's how I undo squaring. That would give me 5/4. Okay, so my ratio of side lengths is going to be 5/4. This means this is probably the large rectangle or triangle. This would be the small rectangle or triangle that we're dealing with, because obviously 5 is bigger than 4. Okay, part B, we're actually going to start applying this. If the measure of one side of a small triangle is 6, find the corresponding side of the large triangle. Well, we have to use this ratio. 5/4 is x over 6. I put 6 on the bottom because that's where the small triangle's at. It said 4. 4 is smaller than 5, so the small triangle, the 6 is going to go on the bottom. I cross multiply, I have 4x equals 30. I divide both sides by 4, and I have a side length of 7.5. What you're going to do is you're going to have a mixture of problems kind of like this, where they're going to tell you, okay, hey, your scale factor is this. I need you to find the ratio of areas. I need you to find the ratio of sides. I need you to find, this guy or that guy or whatever else might be going on. They might give you this part. They're going to give you some shapes, and you're going to have to try to figure out what's going on. If you ever have any questions about this, you can always come and see me. But the key concept here is that to get anything, if you have the scale factor, you can get anything. So here's the scale factor. It's the same as the ratio of corresponding sides. Scale factor is the same as the ratio of perimeters. These 3 are the same. And this guy, man, this guy's a little bit different. We got to square the scale factor to get the ratio of areas.